Hi everybody, welcome to this short explanation video of the Cambridge A-Level Computer Science course. We're just going to be talking about one of the programming paradigms, low-level programming. The other three that are currently in the syllabus are declarative programming, object-oriented programming, and imperative programming. This video is just going to introduce low-level programming. The CPU is constantly processing data that's stored in memory, and to do that the CPU has a variety of different registers to assist. We have the memory address register, the memory data register, the current instruction register, the program counter, and the accumulator. This video is not going to describe any of these in particular detail, but will be referring to them. What a CPU does extremely well is something known as the fetch-execute cycle. So the CPU fetches instructions from RAM, and then it executes the instructions one by one. Okay, so this is there's an instruction set, and the CPU fetches instructions from that instruction set and deals with the instruction. And here is an example of some of the instructions that a CPU will process. Of course, this is all written out in very low-level programming language, similar to, if not the same as, assembly language. So an instruction here is LDM, which loads the number into the accumulator. So when you see this hash, it means we're dealing with a number. Okay, LDD is direct addressing, and it loads the contents of the specified address into the accumulator. Okay, so I'm not going to explain all of these instructions in the instruction set, but I'm going to try and show you how we can decipher a problem relating to these instructions. So let's say that a section of memory in a computer stores these ternary values. Okay, so here are the memory addresses, and this is the information that's being stored. In another section of memory, a program is ready to be run. Here is a program, and we're just going to step through this program and see how it works. Okay, so just before we do that, let's pop this out so we can kind of see everything in one screen. So the first thing that my program is going to do is use this instruction, LDM, on this operand. Remember, this thing here is a number because it has a hash symbol in front of it. This isn't a memory address. This is a number. Okay, so what does LDM stand for again? LDM means we're going to load the number into the accumulator. So let's just see that happening. There you go. That number has been loaded into the accumulator. Sorry, ACC stands for accumulator and IX stands for index register. Okay, so let's step to the next one, LDD 230. Well, let's have a quick look and see what LDD means. LDD is direct addressing. It loads the contents of the specified address directly into the accumulator. So this is the address, 230. There is 230 in memory, and it's storing this ternary value 231. So it's going to load this value directly into the accumulator. Let's see if that happens. Yes, it does. Next we have LDI 230. What's that all about? LDI, indirect addressing. The address to be used can be found at the given address. Okay, this is called indirect addressing. So LDI 230, well, there's 230. This is the number again. This is 231, but this time we're going to do it indirect address. So this jumps to 231 and loads the contents of that address. That's known as indirect addressing. Okay? So LDI 230, it goes to this address, it gets another address, it goes to that address, and it loads the contents of that address into the accumulator. That's how LDI works, indirect addressing. The next one is LDR, hash 1. Oh, hash, this is a number then, it's not an address, this is a number. What does LDR do? LDR load the number into the index register. So we're not going to load into the accumulator this time, we're going to load a number into the index register. There it is, the number 1. Next, LDX 230. What does LDX stand for? LDX address, indexed addressing. Form the address from the given address plus the contents of the index register. Copy the contents of this calculated address into the accumulator. Right, this is indexed addressing. So what this is doing is, the address is 230. We add that to the contents of the index register, which is currently 1. So that's 231. We go to memory, we find that address, and we load the contents of that memory address into the accumulator. So we've still got 5. 5 was loaded. Then we compare what's in the accumulator with what's at this memory address. Okay, let me just check that I've got that right. CMP. Compare the contents of the accumulator with the contents of this address. So the accumulator is storing 5 and this address is storing 0. Is 5 the same as 0? Well, no, it's not. So what happens is, we've got this JPE here, following a compare instruction, jump to address if the compare was true. So that's the next instruction in the instruction set. Now 5 is not the same as 0, so this JPE doesn't happen. That doesn't happen. It's not the same, so we skip that and we go into here. Index register. What do you think that means? You've got it. The contents of the index register are incremented by 1. So it now becomes 2. Now we're going to jump back to 504. Oh, it's like a loop. We're going to jump back to 504 and we get the LDX 230. Can you remember what LDX means? Was it indexed addressing or something? Indexed addressing. Form the address from the given address plus the contents of the index register. And copy the contents of this calculated address into the accumulator. So we've got LDX 230. So 230 plus the contents of the index register. That's 232. That's the address we're going to, 232. And we copy the contents of that address into the accumulator. So hopefully 7 is going to appear. Yes, it does. We're going to compare 7 with 0. Not the same, so that doesn't happen. And we increment the index. It becomes 3. Then we jump back to 504. We're in a loop. Indexed addressing, 230 plus 3. We go and find that address and load the contents into the accumulator, which is 9. Okay, so that's happened. We've loaded 9 into the accumulator. Now we're going to compare 9 with the contents of 235, which is 0. That's not the same, so we're not going to do this. We're not going to do that. We're going to skip it and go to increment. So there we go, we've incremented the index. And now we're going to jump back to 504. Indexed addressing 230 plus 4 is 234. We're going to load 11 into the accumulator. Yep, that's happened. We're going to compare 11 with 0. Not the same. We're going to skip that line. JPE, no. We're going to increment the accumulator. Sorry, we're going to increment the index register. So it now becomes 5. We're going to go jump back to 504. Instruction 504. we're going to do indexed addressing again. 230 plus 5 is 235, so we're going to load 0 into the accumulator. Brilliant. We're now going to compare 0 with 0. It's true. So finally we have a chance to do this thing, this JPE. What does JPE do? JPE. Following a compare instruction, it jumps to an address if the compare was true. Following a compare instruction, it jumps to this address if the compare was true. Well, this time, the compare is true, because 0 is the same as 0. So this is true, so we go to the JPE now. We go to line 506, and it's saying jump to 509. And that is the end of the program. I hope you've enjoyed this introduction to low-level programming as per the Cambridge International Advanced Subsidiary and A-Level syllabus.